bin YUSSOF, and my father is MOHD bin YUSSOF. And we're going to teach you how the line programming formulation and the standard for preparation for platform company using the syntax method to help optimize our production choice. Okay, to kick things off, let's look at our definition of the company. There are three types of product company: there is trend, chart, and cost. Let's see. X1 represents the number of trend produced per week. For the X2, it's represent for the number of truck produced per week. And for the X3, it's represent of number of car produced per week. To formulate the learning programming problem, the objective function is to maximize the profit, and the profit is for the trend is 120 ringgit, and for the truck 18 ringgit, and the car is 60 ringgit. To maximize the product, we need to use 120 ringgit X1 plus 80 ringgit X2 plus 60 X3. Our goal is to find the exact mix of X1, X2, and X3. And X3 that will make this total profit Z as high as possible. Okay, for this slide, we need to do the operational concept. Of course, we cannot manufacture an infinite number of the toy because of the product line face specific research limitation across the three operational departments. Let's break them down. First, for the operation A, a train takes 3 hours, a truck takes 2 hours, and a car takes 1 hour. We have a maximum of 200 available. This gives us our first structural concept: 3x1 plus 2x2 plus 1x3. It's less than 200. Okay, for the second operation, B, here a train required 2 hours, a truck required 2 hours, and a car required 1 hour. The operational capacity limit is 160 hours. This is expressed as 2x1 plus 2x2 plus 1x3. It's less than 160. For the third operation, C, for this final pass, every single toy is used exactly 1 hour across the board, and the total gap is 100 hours. So the constant simplifies to 1x1 plus 1x2 plus 1x3. It's less than 100. Lastly, we include the standard negativity condition. X1, X2, and X3 is more than 0. This implies we cannot manufacture a negative number of physical toys. Okay. To solve this problem with a simplex method algorithm, we must convert our inequality concept into equation. We accomplish this by adding select variable, which mathematically represent the unused or leftover production hours in each operation. Next, S be the select variable for constant 1 and S2 be the select for the constant 2 and S3 be the select for the constant 3. And when we integrate this select variable into our mathematical framework, then we integrate objective function with a coefficient of 0 because unused hours don't bring in direct profit. So our adjusted objective function is Z, so 120x1 plus 80x2 plus 60x3 plus 0x1 plus 0x2 and plus 0x3. For the simultaneously, our structural constant shift into exact equalities for the operation A. For the subject 2, x3 A 3x1 plus 2x2 plus 1x3 plus s1. The answer is 200. And for the operation B, 2x1 plus 2x2 plus 1x3 plus s2 and 160. And for the 1x1 and plus 1x2 plus 1x3 and plus s3 equal to 100. These complex standard from set us up perfectly to construct our initial simplex FADHIL and compute the absolute best, most profitable production mix for the total carbon company. Thank you, and I will be happy to teach you this question you might have. I will pass to this.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Danial. I will continue the number 5 is initial simplex Danial. This is the example initial simplex Danial. Okay, step number 1 is the setup the Danial structure, which is the table and the structure. The structure is the CJ, basic variable, H1, H2, H3, S1, S2 and S3. Okay. Number 2 is we need to fill in consensus row, which is the consensus row is this is the consensus number A, number B, and C. Number A is the 3 to 1 1 0 0, and B 2 to 1 0 1 0, and C 1 1 1 0 0 1. Okay. Okay, step number 3, get the Z0 is how to do the Z0, which is column of CJ times to column H1, which is the 0 times to 3, 0 times to 3, 0 times to 2, 0 times to 1, and you can plus the 3 to 1 is 0 0 0, which is the 0. 0 minus 3, 0, 0 minus 2, 0, 0 minus 1, 0 is to the next column. Same thing you can do. 0 minus 2, 0 minus 2, 0 minus 2. You can 0, 0, 0, 0, 0. And solution pun you can times 0 is 200 is 0. Number 4, after that CJ minus Z0, which is the CJ, this is column CJ is CJ. 120 minus ZJ. 100. 18 minus 0, 18. Next column, same thing you can do. CJ minus Z. This is the complete of the initial simplex terminal. Okay, as you can see, the initial simplex terminal is not complete yet because is CJ minus ZJ is less than 0. Not optimal, need to verify. First thing first, you can do you choose the highest of CJ minus ZJ, which is the column of this. After you choose the highest of CJ minus ZJ, which is the column of X1, we need to calculate the ratio. How to calculate the ratio? The column of solution to divided by column pivot column. Which is this formula: ratio equal to solution divided by entering column volume, which is 200 divided by 3, 100 divided by 2, 100 divided by 1, and the ratio is 66.67 and 80 and 100. Okay, number 2 is you choose the lowest of the ratio. The lowest of the ratio is 66.67. This is the pivot row. After you choose the pivot row, and you can get the pivot number. This is the pivot number. After you choose the pivot number, you can do the next step, which is you can do the first installation, the new table. Okay. Now we go to the all values in row S1 divided by the pivot number to option the first iteration. This is the pivot row for S1. 3 divided 3 equals to 1, 2 divided 3 equals to 2 per 3, 1 divided 3 equals to 1 per 3, 1 divided 3 equals to 1 per 3, 0 divided 3 equals to 0, 0 divided 3 equals to 0, and plus 1, 200 divided by 3 equals to 66.67. This is the new row for the first iteration, which is the initial table, which is this is S1, and this is not to the optimal initial need. Can change the X1 over here, and number for S1, which is in the structure of the first iteration. The number of this fill into row this. After you change S1 to S1, you can do the row S2 and S3. How to get this number? Look to this format. 2 minus 2 times 1 equal to 0. How to get this number? 2 is the 2 minus 2. 2 minus 2 is the initial value, which is 2 minus 2 times to 1 equal to 0. For this, 2 minus 2 minus 2 times to 2 per 3, which is, you can get this, and this 1 minus 2 1 minus 2 times to 1 per 3. 1 minus 2 times to 1 per 3 is 1 per 3. To the next, you can go this command, which is the S3 is the same thing for S2, which is the 1 minus 1 minus 1 times to 1 minus 1 times to 1 equals to 0. And next, 1 minus 1, which is the initial term, 1 minus 1 times to 2 to 3. You can get this. And next lesson you can do the same thing. Okay? After you complete for first installation, you can do the CJ minus ZJ row. You can look at this table is not optimal because of this number is not less than 0. You can do the second iteration.
For the second iteration, you look at X2. Now you get the answer in X2. You will turn it to this form. As you can see, 0 minus 1 per 3 times with 0 and 0. And how do you get this number? 0 minus 1 per 3 you get from 0 minus 1 per 3 times with 0 and we get 0. Now we jump to the next formula. 2 per 3. 2 per 3 minus 1 per 3. We get from here 2 per 3 minus 1 per 3. We time with 1 per 3 and we get 1. Then 1 per 2 we get 1. And we do the same thing for the next answer in this row S2. And then we get 0, 1 per 2, 0, 1 we get 1 per 2, 1, and we get 1 per 2, and we get 10. For the next one, we have X1, H1, and then how we get this answer. 1 minus 1 per 3, 1 minus 1 per 3, we time with 0, that is called S2, we time with 0, and then we get 1. 2 per 3 minus 1 per 3, we generate the first step is iteration, and then we get 1 per 3, then 2 per 3, 2 per 3, minus 1 per 3, we time with 1 per 2, and then we get 1 per 2. Same goes to the next one. For the ZJ column, how we get this answer? Can we make it CJ? CJ we times with X is Y, so we get 100 jump to next week 120 times with 122, and then we get 90. Every column we time with 120, and we get 60, 90, 0, 150, and then we get 900. That's how we get 60 AZ. And now we do CJ. CJ minus ZJ. How we get this answer? So we must do CJ. This is CJ minus with ZJ. Minus with ZJ. So we get 100 minus 120 minus 120, and then we get 0. Same goes to this area. 80 minus with 90, and then we get negative 10. We do the same thing to the next column. So we get 0, negative 90, 0, and then we get negative 150. Okay, we can see at this table. We can look here, it's already optimal and no need to modify because of it's less than 0. Okay, as you can see, it's negative 10, negative 20, negative 150. So it's optimal. Then for the final optimum, we can see x1 is 50, x2 is negative 10, x3 is 50, and s1 is negative 90. S2 is 10, S3 is negative 150, and then for the Z it's already 900 centimeter.
Profit.
For the final optimal solution, we get x1 is 50, x2 negative 10, x3 is 50, and s1 negative 90, s2 10, S3 is negative 150, and the maximum profit is 9,000. And then for the interpretation, it's 50 for trends, 0 for trucks, and 50 for cars. That's all for me, for the HANAFI YUSSOF, and Danial being Muslim. And that's all for us. Thank you for listening.